really grow. I just have to do the opposite for the when a input comes and hits the effect. And we can also do the same thing when a output sound comes and hits the gate, the exit, or the effect again. Another thing we could do is just make the effect sound allow to act as input to the output, input to the effect. That would be one line of code, but I've purposely disabled that so we don't get so much noise. So which is the most practical out of these three? I'm looking at the muting the mic, gradual populate, gradual deletion. Muting the mic would definitely clean the screen up a lot. We have to think about how we want to do this though. So I'm reaching the level of functionality where it's a really good time to just sit down at a coffee shop and draw out all the functionality I want based on what I can see being possible within a month. Yeah, I want to finish this within a month. That's the... Well, at least have, you know, something that I could release and not be embarrassed about in a month. Maybe not the graphic part, but at least everything else. What was I about to say now? Ooh, okay. It's almost midnight. Do I want to give up? How about we just mute the mic? And note that by saying, when I say mute the mic, we don't have to mute the mic. We just have to bypass the processing of the input. Because we're not doing any straight throughs. The sounds are all the result of analysis and processing. So that class is called Input Manager. Yeah. So one thing we could do Ooh, this is tricky. It's tricky because there are many cases, such as when I'm saying something, so I'm inputting something into the mic, so it's already on set, and then some sound object goes and hits a wall, so at that point we should make a sound. I guess the ideal thing is it doesn't make a sound, and I continue to make so essentially the output gets muted. That's another option I wasn't thinking about. You can mute both the output and the input. So if you're recording something already, you probably don't need to hear stuff. That's an interesting idea that I like. I at least want to experiment that. So let's try that quickly, and then we can look at the inverse, which is muting the input while we have output. And I mean, getting some version of this up is not so hard, but dealing with the latency stuff is probably going to be a little tricky. So let me get into my serious posture. That's sitting on my chair, cross-legged. It's not actually very serious. So let's procrastinate quickly with a drink of water. Oh yeah, water's good. Hawaii water used to be actually very, very good. When I came back this time, I noticed a lot more chlorine in it. Muting output when we're taking input. That one shouldn't be so bad because I can essentially just stay in input manager.mm and filter audio IO.mm, which are both C++ classes and are singletons. So I can just make a function if it's not already there. That's it's called mute, and I still want to process the audio. I just don't want to add to the I just don't want to write anything to the output buffer, but I still want to delete sounds and such, so that when we resume the sound, we don't have audio delayed however many seconds. Yeah, so there's a start AU graph and a stop AU graph. There's nothing else. There is no mute. So let's go ahead and define a mute function, which is pretty useful anyway. So that's going to be called... Oh, I just realized this is probably going to be tricky. No, it's not in this class. I take that back. I take that back. Yeah. It is in the mixer class. Yeah, because this is the class that does the actual mixing and writes to the actual buffer. Yeah. So a mute call is actually very easy to do if we don't get fancy. Sometimes you get fancy, but sometimes you just you just do it caveman style. So this is what I'm going to do. There's in the not the update call, but the write to buffer call. This is when we send stuff. The input is actual output buffer stuff, and this is all we do. And we need to do this so that the internal buffers and such actually do something. They actually... What was I about to say? They actually process their state and advance along with the time. Does that make sense? They advance along with the game state, the visual game state. So there's not going to be some weird delay. So we do that normally, and then we just bash the buffers. You can do that with a memset, and that might be, yeah, that would be a little faster than a multiply. If you're not muted, you can also just, you can rescale the volume, because no, we don't have any scale factor going into this. But that's a feature for another day. Right now we want a mute. So I'm gonna say if m mute then we just do memset buffer 0 nb size of sint 16 times 2 plus times 2 times nb sems. Right? Now all we need to do is have mmute somewhere. So mmute doesn't exist yet. So let's go ahead and make sure it does. Wait, there's a mute all call. What does that mean? I didn't see that. What's that? There's no mute all call. I guess the compiler doesn't worry about the linking issue because it doesn't get used. That's sure lenient of the compiler. Well, and totally fine, I guess. It means it checks a lot of stuff. What was I doing? Yeah, I was creating... I just have to create that mute all call. I don't have to do anything else. Mute. Oh, I was somewhere. What was I doing? I wasn't doing anything at all. Okay. Void mute all. Get this guy. Put it there. And mute. Instead of mute all, how about set mute? And we'll say mute on. No, just mute. Mute on is confusing. And we do have, we require a boolean mmute. And we can init that to false. So how's that look? This will do the trick, right? We just need to add set mute. Right here. So now we got set mute. And we're just waiting to use it. This is tricky now. So I realize now this should be interesting. This is only going to solve half of the problem. Okay, so